before we go through the preliminary matters, just the first thing I wanted to do, I understand that we have Ms. Amy Young online from the Impact Assessment Unit. And I just wondered if we could maybe just run through that first. I understand, Ms. Young, that you have received the questions from the committee. Maybe if we just cover that off first so we can let you go, and then we'll move into the other preliminary matters, unless there's any. Okay. All right, Ms. Young, do you want me to repeat the questions, or are you happy to sort of give an introduction before you provide a response?
I don't have any introduction. If you want to just go through the questions, we can do that.
Okay, no worries. Okay, so the first question was in relation to the Cultural Heritage Management Plan, and the two questions were whether the Guttram and Benwell have an approved CHMP, whether that includes the tangible and intangible cultural heritage values.
Yeah, this one I think is a question for the decision maker for this CHMP, which is FPSR. DTP-IAU have not seen the proposed or approved CHMPs, so we can't answer that.
Okay. Problem. Okay, and then the next question was, if the CHMP has been approved for the Guttram and Benwell project, is it correct to assume that the minister is only seeking the advisory committee's recommendations on the cultural heritage values for the Gunbower environment?
No, so while we haven't seen the CHMPs, we do know that the activity area in the CHMP only covers the construction footprint and construction activities. The MIE and operation of the project is not covered by either CHMPs. Therefore, the inquiry's examination of these matters and recommendations should still include both project areas as a matter for the Minister's consideration in her assessment of the potential effects.
Okay. And then moving on to state offsets.
Mm-hmm.
I think we provided some extracts there from DECA's submission, which I won't read out, but just for the benefit of people online or trying to cross-reference, DECA's submission was submission number 12, and their indication that they were likely to grant an exemption under the conservation provisions in the planning scheme. Is that something, if the exemption hasn't actually been granted at this stage, are you expecting the committee to provide advice on offsets?
Yes, as noted in the terms of reference, please consider information provided in the environment report, submissions, and information presented in the hearing in providing the advice in the SIAC report. I'd also say please remember that DECA's written submission was made on the information in the environment report and does not consider any new information presented at the hearing.
Okay, thank you, Ms. Young. All right, thanks, Ms. Young. Thanks for turning up this morning at relatively short notice. We appreciate your time.
No problem.
And be excused. Thank you.
Thank you.
Okay, I'll just move on now to the other preliminary matters. So, Farrell, looks like you've got something to question. Do you want to?
That's okay. No, I was just we had some responses with the questions from the committee, so we're in a position to go through those if you like.
Okay, all right. We'll do that in a minute. I'll just go through the very basic things first, and then happy to come to your answers as well, since we're doing a Q&A this morning. So, okay, so the first one, I think the proponents received a copy of this correspondence, but Ms. Hunt from the Friends of the Koala group said she was unable to attend online and has just indicated she's got a question to present to all the witnesses. The committee is proposing to just read that question out on her behalf today, so I think that the witnesses have probably seen the question anyway. We haven't received any requests, other requests for people to do cross-examination, so we did indicate in the directions that people need to give notice that they want to ask questions. Just checking online if there's anyone who forgot to send through their request. that is a no. Next, more of an administrative thing, but we don't need Mr. O'Farrell and Mr. Forrester, we don't need you to qualify the witnesses in the formal sense, so just an introduction of the name, we've read the reports, and if there's any corrections, that will be fine. And the other, this is kind of a general comment, but also relevant if you're directing us to the environmental delivery standards, if you could just point out if there's something where you're seeking a variation from the previous version of the EDS. I know we've talked about how that might be tracked, but as well, if you're presenting any questions, if you could just flag that at the time. I'm sure you will, but it just helps us. Okay, that was all the preliminary matters from the committee. So, Mr. O'Farrell?
On the Friends of Koala submission 10 question, if it saves some time, we can answer that question now by saying the answer to it is no in relation to all witnesses.
Oh, okay. All right. Thank you. We might be running at a very efficient timetable today.
And then in terms of some of the questions, in terms of what Ms Young said, I think we can broadly say that we agree with everything in terms of how they put it, in terms of how they're interpreting and responding to you on the terms of reference. But to answer some of the questions, we'll just put a little bit more on this. So the incorporated document conditions relating to native vegetation. And so the day one changes proposes to delete condition 6.3.3 through to 6.36 from the draft incorporated document. And those conditions that relate to the offsets. And the inclusion of those conditions was in the exhibited version, and consistent with the incorporated document conditions in the previous packages. So that's both at Hatter Lakes North, Ballasea Youngera, under Amendment GC 202, and also for Naya and Vinifera under Amendment C 78. So if I call them the central packages, those conditions occurred in circumstances where the relevant regulator, being the Secretary to DECA, had not previously agreed that the removal of native vegetation for the projects would achieve overall improvement to biodiversity, such that native vegetation offsets were not required. Here, the exhibited version of the incorporated document had a note that indicated that it might be appropriate to remove those conditions, 6.3.3 through to 3.6. If it was demonstrated that the removal of native vegetation for the projects would achieve overall improvement to biodiversity without attendant residual uncertainties.
Can you just repeat that last little sentence you said?
Yeah. If it could be demonstrated that removal of native vegetation for the project would achieve overall improvement to biodiversity without attendant residual uncertainties.
Yeah.
So what our submission to you is that the conditions are not necessary for two key reasons. The first one is that the AOIBs that are included in the environment report are consistent with those that have been approved by the Secretary for the central packages. But unlike when those conditions were imposed for the central package, you have here satisfaction expressed by DECA in submission 12 that the AOBs demonstrate that the projects provide for overall improvement to biodiversity. And it's for those two reasons, but in particular the second, that we submit that those conditions are not required. There was also a question, I think, from you, Member McMillan. You asked about the timing of advice and decisions in respect of offset requirements associated with native veg removal, and whether it's possible for you to reach conclusions in respect of them without a formal decision having been made by the Secretary in relation to a conservation work exemption. And I'll start at the end and then I'll come back to the start. The end of it is that the incorporated document would be a planning control that we're seeking your advice to the Minister to support without the conditions. Now, if the Minister accepts that advice, it effectively switches off clause 52.17, and so you don't need the Secretary's decision. And we'd say that you're in a framework where you don't need to wait for the Secretary's decision. You've got a submission to you and submission 12 from DECA, provides you with sufficient comfort to support the submission we're making to you in relation to these conditions. So then if I just go back to the start again, I don't think I need to do that. I hope you understand the point we're making.
Yes, I understand. So just on that last point you made, Ms Young just indicated that obviously the submission was made at a point in time, and there's been submissions and things that have occurred after that. Do you have any comments on that at all, or whether
that's our submission as things stand. We're
Yeah.
conscious that DECA's still got to come in front of you.
Yes.
And our position might respond to something different if there's a shift of position from DECA.
Yes.
So,
we'll hear from them later? Yeah, okay, no problem.
Just to
and
clarify,
then you'll need to deliberate, of course. For some reason you might not accept what
just to clarify, Mr O'Farrell, are you suggesting then that what was submitted in the environment report really hasn't changed in terms of biodiversity assessment? Since exhibition, what we hear from experts, but not actually substantial changes to that assessment.
I think what you have now is a compendium of material which includes the PRS, the day one documents, submissions and the evidence. All that in the submission. So that it has been updating information.
Okay, thank you.
And just on that, Member Elliott, all that points to support for the IOBs.
And no doubt we will hear more about it from the expert on Commonwealth offsets.
Yes, well, I was going to address you on that now.
Thank you.
So the relevant to the Commonwealth matters, again, we can go to the end and say the Commonwealth matters are Commonwealth matters. You've all been tasked with the matters here as it relates to state on the offsets. So when it comes to Commonwealth, it's also part of your task. Assessments are not having a significant impact, so that Commonwealth offsets won't be triggered. So that's the end point, but I just go back and work on a bit more detail. So the inquiries we understood it was whether DECA's satisfaction and or our client's proposed day one changes also covers off on offsets which may be required having regard to impacts relevant to the assessment of projects under the SIAC. And our answer in respect of that is no. That's a submission. It does not cover off. And that the environment report and the specialist assessments, and I should say also the evidence, do not identify any significant impact on matters of national environmental significance. And and there is no requirement for any offset under the EPBC Act. Second part of that is that the proposed Day 1 changes relate only to native vegetation offsets under the Victorian framework relevant to the incorporated document. Not intended to affect any assessment or approval under the EPBC Act. We will lead evidence and make submissions that establish that the projects would not result in any significant impact on matters of national environmental significance. And that the environment report demonstrates that the projects would achieve specific benefits for matters of national environmental significance. And that the IOBs in the environment report demonstrate that the projects would achieve overall improvements to biodiversity. And our submission will be that those matters justify the proposed Day 1 changes, and in conclusion, that the projects would not result in any significant impact on matters of national environmental significance as relevant to approval under the EPBC Act. You might have noted that I'm largely reading from a document. We've committed this to writing, and you might find a resistance if we just file that, even though you let it the other day.
Cool. Yeah, thanks.
We'll arrange for that to occur. There was also a question from Member Bates about that expression pre-regulation in similar terms, and you asked about that, Member Bates, in regard to the expression in the DTP referral that referring to the predicted biodiversity improvements of the project in relation to pre-regulation, that is prior to project implementation. So page 13 of our opening submission identified that the use of the term pre-regulation to refer to conditions prior to project implementation does not align with the language of the environment report itself. So the environment report and VMFRP more broadly refers to pre-regulation conditions or conditions prior to regulation to mean conditions before regulation control the flows within the basin, within the Murray-Darling Basin, which commenced around the turn of the 20th century. So these are the conditions that the projects have as their reference point when considering better alignment of inundation with pre-regulation or natural conditions. And on our reading, the referral letter uses the term pre-regulation hydrology to refer to hydrology of the floodplains before the construction operation of the project infrastructure. And in this way, the referral letter identifies that it is particularly important for you to examine how the projects compare with the do-nothing approach, whereby the floodplains will be left subject to current regulated hydrology conditions in terms of biodiversity outcomes. In the document that we filed, we put together a reference to a graph that's figure 3.3, which is showing the current regulated hydrology conditions of regulation and post-project conditions as VMFRP with the basin plan. So I'll show you that. And also the environment report also presents an assessment of how projects of works and operations would change the existing altered hydrology of the floodplain by reference, for example, to differences in depth, shear, stress, and so on. Dr. Treadwell will address those matters further as well. And then, just for completeness on the CHMP inquiries from the committee, Ms Young hadn't seen the CHMP for Gutman and Benwell, but we can confirm that it does include consideration of both tangible and intangible values. As explained in the environment report and Ms Oldaway's evidence, the preparation of both CHMPs involved was informed by consultation with traditional owners and interested parties, including in respect of intangible values which may relate to the relevant activity area, we submit, it's important to note that the CMPs are prepared on the basis of the principle of self-determination, free and informed consent, such that the choices of the traditional owners and interested parties to share or not share information about values and to share on the basis that values would not be recorded within the CHMP or other relevant documents were always respected. And our submission is that we consider that approval of the CHMP for the Guthrum and Benmore project, it's a matter to which inform the committee in relation to consideration of potential construction impacts on Aboriginal cultural heritage. It demonstrates that potential construction impacts have been properly assessed and will be appropriately managed, and does not reduce or remove your task to consider and provide advice in respect of potential impacts on and benefits to Aboriginal cultural heritage, which extends beyond construction impacts. Hopefully that brings us up to date on the answers to the current questions. If there's anything else that arises, of course, do our best to answer them now.
All right. Thank you for providing that response.
We'll arrange for that document.
Okay. I just want to mention another thing. Just noticed that the construction has just started up. We do have hearing room 2 free. So we have the option of moving now. I think I can see Ms. Selvaraj looking at room 2. I'm just wondering, I know it's a bit of a disruption now, but I'm just checking with the parties if you'd like to move now and then run through the witnesses in hearing room 2, or I think we have plenty of room for everyone else in the room, but we just have to have a little break now. It's up to you.
We don't mind. I think my experience is that if there's noise there in here, it'll be in there as well.
Okay.
But
All right.
if you want to give it a try, I'm not sure whether.
Okay.
Yeah. All right.
Amy
Well, we'll
knows
just
that
stay
it's
here
next
then.
door.
We'll stay here. Yeah. Literally play it by ear.
Yeah, there we go.
Oh, Ms. Young, sorry. Yeah.
No, that's okay. It's not an official matter. I was just going to say, with the background noise, if in the room, you might need to speak up just a little bit, because there are some moments where it is difficult to hear what's being said over the background noise. Not all the time, just now and then. So if everyone speaks up, that'll be okay.
All right. Thanks, Ms. Young, for the feedback. All right. Okay. So now we're ready to hear from I'll just group them as the water expert. So I understand we had Mr. Tate up first.
Yes.
So over to you.
Thank you. Well, you know who the witnesses is, and Mr. Tate, in your written statement, is there anything you wanted to add, subtract, or correct?
No.
You had a series of slides that have been circulated. Is there anything in that series of slides you wanted to add, subtract, or correct? Do you adopt both of those documents as a true reflection of your opinions in this matter?
Yes.
Attend to that, please, Member McMillan. And I think you heard the direction from the committee, Mr. Tate. You can proceed on the basis that the committee's read your report, and 30 minutes has been allocated to you. You may or may not need that time, and if you need a little bit more than that, I'll get it on the clock and I'll ask the committee for permission for some more time. Could you provide a summary of your evidence or present the slides to the committee, please, Mr. Tate?
Okay, so my name's Ben Tate. I work for a consultancy called Water Technology, and I've been leading our national flood mapping team for around 20 years. I got involved in this project in late 2025 when I peer-reviewed DHI's hydraulic modelling for the project. I discussed my review over a number of workshops with them, and they've reviewed the public submissions on the project and have prepared an expert witness statement. I've got a couple of dot points there on some of my relevant experience. I won't go over that for the sake of time. And here's just a quick summary of the scope of my instructions. Again, I won't dwell on that. As we're in the second week of the hearing, I presume I don't need to spend too much time on the site location. But on this slide, I'd just like to point out that for Gumbower, the project area is split into two water management areas, the upper Gumbower water management area and the middle Gumbower water management area. Heard of those during the presentation. And I'll just run through some of the surface water features of each of the sites in the next couple of slides. So as the hydraulic modelling is aiming at sort of replicating natural flood events so that we can be confident that the model is able to do that, and we can then confidently predict what's going to happen when you've met the proposed works. I thought I'd just quickly run through, I guess, the flow behaviour or the flood behaviour through each of these sites. We'll start on the right of the slides here in the upper Gumbower water management area. An important feature to point out, and I presume you can see my cursor moving around on the screen there, is the Turrumbry weir pool here. So the upper Gumbower water management area straddles the weir, which means the section of river upstream of there is elevated quite a bit higher than the section of river downstream under normal sort of flow conditions. I guess what this means for the site is that Cameron Creek, that joins the Murray upstream of the weir, is connected to that higher weir pool that have some permanent water that's able to enter Cameron's Creek in the upper forest. In Murray River flow events, when we have a bit of a high flow, we get water that will flow through Cameron Creek and into the upper forest, and that flows down into Black Charlie Lagoon here, and then in higher flows that'll flow on into Bagot Swamp, and can then flow into the middle Gumbower water management area via Dry Tree Creek. As well as sort of flows entering the forest through Cameron's Creek, flows can also enter the forest through a number of points along the Murray River where the banks are a little lower than in other sections, and I've indicated that here with the little pink arrows. They're the lower sections of the bank where we often see flows entering the forestry. Once we're down in the middle Gumbower water management area, water will inundate Emu Hole Lagoon in this area and flow on into Pig Swamp. And from there we have two features that are worth pointing out that intersect the floodplain. Old Straight Cut, which is a man-made channel constructed many years ago and has sort of high banks on both sides of the channel, but it has a couple of little cuts in the banks so that water from upstream can pass through it and can flow downstream. And that'll continue to flow down towards Deep Creek here, which has a very similar setup. Again, it intersects the floodplain and has some little cuts upstream and downstream on its banks. Again, the water flows through that creek and can continue further downstream, flowing into Broken Axle Creek and Spur Creek and the Red Rice Swamp. From there, water will then flow out of the middle Gumbower water management area and into the lower Gumbower, into the sort of TLM project area. For Guttram and Benwell, the inundation mechanisms of these floodplains are a little bit different to Gumbower in that they both fill from the downstream section. Get rid of that. They both fill from the downstream section of the floodplain first. So the little pink arrows here on the downstream end or the western end of the floodplain are the points where water enters the forest first. And then as the Murray River flows increase, water starts to then spill in from the upstream eastern inflow points at both of the floodplains. With sustained flow or higher flows, that water eventually fills up the floodplain and you have water flowing through the floodplain from upstream to downstream or east to west. So just some background, I guess, into the hydraulic modelling. So DHI started some modelling in 2022 for North Central CMA on both of these forests. And in 2024, they then updated their modelling for Lower Murray water. And that included both the water quantity modelling and also water quality modelling. The objective of that updated modelling was really to take the latest technology and modelling techniques to improve the models, to better describe the connectivity between the river and the floodplain, and to produce models that were of a sufficient level of accuracy that would allow potential project impacts to be identified, particularly regarding afflux or increases in water level, inundation outside the project area, erosion, and low dissolved oxygen water issues. As I mentioned earlier, in late 2025, I reviewed that updated modelling, and DHI finalised their modelling reports incorporating some of my feedback from the review, and the modelling methodology and their results are fully described in those two documents that I've here on the slide. All right, so I'll move on to, I guess, the modelling methods. DHI for the water quantity modelling used a software called Mike Plus, and this software allows the modeller to integrate one-dimensional hydraulics with two-dimensional hydraulics. And I guess just to try and explain what I mean there, the one-dimensional hydraulics describe flow in features such as channels or culverts or pipes, rivers, where the direction of the flow is set. And with increased flow, water can increase in speed, but it can only move in one dimension, and that's up, so the depth can increase. The two-dimensional modelling is a little more complex, and there's no predefined flow paths, so that when flow increases, water can both increase in depth, but it can also change in direction and spread out across the model. So combining both the one-dimensional and two-dimensional hydraulics is really useful for floodplains like this, where you have both creek flow, we've got some pipes, and then we've also got quite complex floodplains and wetlands where water spreads out in all directions. The software that they've used, Mike Plus, is also used right around the world, so it's a suitable software choice. The water quality modelling used a very similar hydraulic model as its basis. Mike 21 is sort of a cousin of Mike Plus, if you like, and they then coupled it with Mike Ecolab, which is a module that can add on to the top that then models off chemical and biological processes that are required to represent oxygen. One of the advantages of the Mike Ecolab software over, I guess, some of the methods that have previously been used to look at water quality in the basin is that it allows you to break down the site into, it allows you to understand the water quality in a bit more detail across the site. So instead of just treating the whole floodplain as one unit and the water quality being the same across the whole floodplain, it allows you to look at where the water quality it might be a bit different in different places. So some sections of the floodplain might have a lot of water flowing through and there's lots of dilution, and then others stagnated and not be turning over as quickly and might have different water. It's quite a good improvement in previous modelling techniques. on the input data for the, so these types of models require topography data or ground information. They require inflow and outflow boundaries, evaporation and infiltration losses, land use cover, roughness, which I'll describe a little bit in a second, and water quality inputs like temperature and leaf litter loads, decomposition rates, all those sort of things. In my opinion, the inputs that DHI have used into these models are appropriate. And I'll just talk a little bit more on the roughness and the topography. So when I talk about roughness, that's basically describing how rough the surface is. If you, for instance, if you have water flowing down a smooth concrete line drain, it'll flow quite fast and the water level will be low. If you throw a heap of rocks and vegetation and things like that in there, the roughness is higher, so the flow slows down and the depth gets higher. So the roughness, I guess, is characterising it, how rough or smooth that floodplain is. It's an important parameter for the model. When I first reviewed the models, I thought the roughness values were perhaps a little low for forested area like this, but after sort of looking into the calibration and the performance of the model is reasonably calibrated, which tells me that in combination with all the other model parameters, that the roughness values were appropriate. Onto the topography and the ground levels. This is probably one of the single most important input into the models. Really dictates where water can flow. The major data set in these models is an aerial laser survey. And so that's some equipment that's fixed to the wing of an airplane or a drone, and it flies over and it captures the topography of the ground across the full floodplain. So the benefits of that approach is that you can capture really large data sets quite quickly, and it gives you really excellent spatial representation of topography. One of the common issues with laser survey is that the lasers do struggle to penetrate through water or through really dense vegetation like reed beds and so on. It's fine in penetrating through tree canopies and things. So what DHI found in their calibration is that there were some areas in their models where there was obviously water at the time of the flight of that survey. Thick stands of reeds, which you probably saw when you were out on site. And so what they've done there is substitute some of that topography with field-based survey, where you have people physically out in the field measuring points. And they've also looked at making some adjustments to some of the areas of that laser survey to lower them and to better represent the true bed level of some of those wet, swampy areas. And I guess they've proved that method by calibrating their models and comparing them with extents to satellite imagery. And so I think that's a good approach to dealing with that challenge. I'll just point out a couple of things on that aerial laser survey. The products that were used for these models were from 2001, 2009 and 2015. And while some of those surveys are a little old now, they're the best available information. So I think they've used the best available laser survey that they could find. The other thing to note there is that in 2022, when we had the flood event on the Murray River, there's quite a lot of levee building that was happening right along the river, both from landowners and emergency services personnel. And so some of those levee crest elevations may have changed since those survey products. There's a little bit of uncertainty there around today's heights of the levee crests. The model performance. So as I mentioned before, the DHI did calibrate their models to a number of flood events, and they selected the 2010-11 flood, the 2016 flood and the 2022 flood, and they compared the inundation extents from the modelling to satellite imagery that was captured throughout the event. So in each of those events, there are satellite images from numerous days, and they compared the inundation extents to each of those images. There's an example that I've provided there on the slide from Guttram and Benwell, where the dark sort of colour underneath is what the satellite's seeing. It's showing where the water is on that day, and the hatched blue polygons are the modelled flood levels. On review of the calibration, sort of in its totality, I believe that it's a reasonable calibration, and that model is appropriate to be used to then go and test how the proposed future works might impact flow behaviour. Okay, so on to some of the findings of the modelling. At Gumbower, the modelling showed that with the proposed works, the water levels in the upper Gumbower water management area would be slightly higher in that Baggots Creek area, but that the inundation was contained within the levee, so there's no impact there. In the middle Gumbower management area, the water levels again were slightly higher post-works. And what the modelling showed in that area was that in larger natural floods, when the perimeter levee is overtopped, the water levels are slightly higher outside of the levee, and that may result in an adverse impact. And I'll talk about that a little more on the next slide. At Guttram and Benwell, similar finding. The modelling showed that post-works, the water levels were around 3 to 6 centimetres higher in the Benwell floodplain. But again, they were contained within the project area, within the levee, so had impact to outside the project area. On the water quality modelling, the modelling for both Gumbower and Guttram and Benwell shows that hypoxic conditions may result during a pumped environmental watering scenario. So the dissolved oxygen levels are quite low. Noting that hypoxic conditions do occur naturally in these floodplains, and that in the Gumbower scenario, that no hypoxic water leaves the floodplain and returns back to the Gumbower Creek is contained within the floodplain. At Guttram and Benwell, there is a small volume of hypoxic water that would return to the Murray River in the environmental pumping scenario. And when you look at the volumes of the water compared to the volume of the Murray River flow, it's quite low, and it's likely to be diluted quite quickly. Dr. Trevor. As I mentioned in the last slide, in the middle Gumbower area, the modelling did show the potential for an adverse impact during larger natural floods when the water may overtop the perimeter levee. And I believe this is proposed to be mitigated and managed in accordance with the Environmental Delivery Standards, SW4 and VMFRP, which I've snipped in there on the slides. So I believe there's provisions there to deal with any potential adverse impact. In terms of the submissions, we'll note that the DECA submission did note that the hydraulic modelling by DHI resulted in an improvement in modelling compared to previous, and increased the confidence in the project outcomes. And there were no other submissions that were relating to the hydraulic modelling. So to conclude, I believe the modelling methodology adopted for the project is adequate to meet the project objectives, including assessing inundation extent, depth, duration, velocities and discharges, and to assess the potential impacts in relation to afflux, inundation outside the project area, erosion, and the low dissolved oxygen. The modelling has identified a potential adverse impact in relation to afflux in that middle Gumbower area, as I mentioned before, and this is proposed to be mitigated and managed in accordance with the environmental delivery standards. And it's my view that the exhibited environmental delivery standards relevant to my area of expertise, being surface water, is appropriate and will ensure that environmental effects of the projects relevant to my area of expertise will be suitably managed to achieve acceptable outcomes. As such, I don't recommend any changes to the EDS for the projects.
Right, thank you.
Yeah, I just have questions. In terms of the models that were used, are they the best available?
Yes.
And this may be a question for one of the other experts, but I'll ask you. Why do the hypoxic conditions occur?
Yeah, I can give you a hydraulics perspective on that, and I'm sure Simon Trevor will be able to elaborate. The hypoxic conditions occur when water enters the floodplain. It washes carbon into the system, so leaf litter and so on. That leaf litter then is decomposed, and that results in a reduction in the dissolved oxygen in the water.
So in this context, it's because there's additional water going into the floodplain, and that water effectively, while it's sitting there for a while with that carbon load, is causing the condition. Is that
correct? What happens also in natural?
Yes.
Yeah.
Thank you. I've just got one question. On page 7 of your presentation, you mentioned that you reviewed the most recent modelling and that they incorporated your feedback. I was just wondering if you could elaborate on what that feedback was.
Yeah. So I'd also worked on these project areas through TLM, so I've got a fairly strong background and understanding of how flow behaviour works in the project area. So there are a few things, I guess, that I was able to share with DHI based on my experience there. There were some comments around some of the LiDAR or the aerial laser survey assumptions that I mentioned and the challenges there, and through some of that discussion, DHI were able to demonstrate how they did a fair bit of work in trying to resolve some of those challenges with representing the swampy wet areas, and I was satisfied with what they'd done. There was, I guess some of my feedback was more around requests for further information in their reports, which again, I'm satisfied that they included that.
Had one question. You just mentioned that the LiDAR data from the latest was in 2015 and the levies had been constructed in 2022. And you were just mentioning, there was some survey work done on ground. Do you think that, I mean, I assume you've been out in the field. Do you think that would affect your conclusions or recommendations in any way?
I know that the levees that were constructed in the upper forest along the river levee have been taken down since.
Sorry, which forest?
In Gumbower.
Gumbower, yep.
So at Gumbower, there's basically two levees. There's one they call a river levee. It's right along the bank of the river, and then there's one that's called a little levee, which runs around the edge of the forest, between the farmland and the forest. So I think that the my understanding, the river levy has been taken down in locations, so likely acting the natural flood flows from the Murray River. The perimeter levy, additional works were done to sort of top it up in the 2022 event. I don't think it impacts the project negatively. If anything, the levy's a little bit higher in that middle forest area. It might well be reducing the adverse impact. So I don't think any levy works on the perimeter levy a detriment to the project.
Just from the site visit, I recall. Now I'm just going to try and get the right location. In the Guttram Forest, there was some. I think there was the 2022 works along the river there. Is it this? Do you have a different response to that, or is that the same? Gumbow.
I think if you recall, back on one of the earlier slides where I showed the little inflow points that are coming.
Yes.
If those levees aren't blocking those sort of low inflow points, unlikely to have an impact on flow behaviour in the floodplain.
It's your understanding that they're not blocking them?
Well, I'm sure. I imagine as a detailed design would be considered.
Okay. Just to close off, I understand that you've seen the question from the Friends of the Koala and Mr. O'Farrell answered the question, but I'm just checking you haven't, there's no different answer. Yeah, okay, all right, thank you. All right, well, that was all the questions from the committee. So thank you for running through that very efficiently and
Mr. Dave, excused?
re-examination or?
No, thank you, Mr. Dave, excused.
Yes, no problem. For the next expert. Yeah, happy to get rolling. Yeah.
Move on to Oxley. While he's coming to the table, I'll just identify his witness statement as document 35, and it has the attachment, the groundwater modelling technical report. Ask in due course for Mr. Oxley to introduce that document. And then his presentation is 50.
Excuse me for a moment.
Oh, no,
Are connected and
fine.
sorted.
The minute you go. Maybe just a sound check for someone online. Can you still hear properly?
Yeah, we can hear. Yeah, we're right. Thank you.
Thank you. Mr. Bartley, wondered if, I think there's a different computer. If you could just swivel that computer next to Mr. Hoxley so it's pointing.
Would you like me to sit in front of this one?
Yeah, as long as you can see what you need to see. Yeah.
Look at that.
Thanks, Mr. Oxley. All right, you're the you were the discipline lead and primary author for Specialist Assessment B in the Environment Report, and you've heard me introduce your witness statement and the further technical memorandum for which you were responsible.
I have.
And are there any additions, removals, or corrections that you need to make to those documents?
There are none.
Well, on the basis that the committee's read your documents, can I ask you, please, you're sharing your presentation, to now step through it with an aim to that about half an hour presentation.
Certainly.
Thank you. Good morning. I will try and speak up to make sure I get over the construction noise and everything. I hope everybody can hear me. So I was the discipline lead for the groundwater and hydrogeology assessment for the ERS package. And through the process of that assessment, I oversaw all the data collection. I had a number of people working for me and with me at that stage, but in the end, the collation of the information and the final report was put together under my supervision. I'm going to give a bit of an overview of the findings of the assessment, and then I'm going to go through and talk a little bit about each of the areas and the groundwater conditions that are at those areas and the nature of the effects of the projects on those areas. But to start with the overview, there are similar conclusions reached for groundwater effects of both projects because, in essence, the groundwater currents at both sites is quite similar. Overall, we found that there's an insignificant effect to groundwater values expected as a result of both projects. There are insignificant to minor changes in groundwater processes, mostly relating to groundwater level changes. So groundwater may go up or down a little bit. Groundwater naturally responds to river level changes such as floods, and it's got a dynamic nature in the floodplain. So groundwater will come up when there's extra water going in and drop down in the periods between them and that river level. We expect that pattern of behaviour to continue with the projects. And in both projects over time, what we expect the core residual effect of the project is that there may be a slight rise in groundwater level. Effectively, this is because with the addition of more inundation in the area, more water going into the soil, a little bit of that will stay in the groundwater over time and the groundwater levels will rise up. A little later on in the presentation, I'll show some groundwater trends and explain how that relates to groundwater level. At this point, I want to make a bit of a point of clarification around groundwater level versus depth. In the presentation and the assessment, I refer at various stages to groundwater depth, which is depth below the surface. So when groundwater levels rise, the depth becomes shallower. Now, sometimes you use these terms interchangeably, and it can be a bit tricky to get on top of when we're talking about shallower groundwater or deeper depth, which way it's going. But when we're talking about depth, the deeper depth means that the groundwater is going down, whereas a shallower groundwater level means it's rising up. But both projects essentially will see this rise and fall through the operation of the project and through natural events with a small cumulative increase in groundwater level over time, so slightly shallower groundwater. We also expect there to be increased evapotranspiration, that is the combination of evaporation and tree or vegetation water use, the process of transpiration, as a result of groundwater recharge. So we get water that goes into the soil and also moves from the soil into the groundwater system. That's slightly shallower groundwater, particularly the shallower groundwater immediately after an event, means that the water is closer to the roots of deep-rooted and shallow-rooted vegetation in locations. It's more accessible. And as a result, that vegetation will use that water. That's actually one of the benefits of the project, that by putting the water into the soil and into the groundwater, that's then available after the flood or the inundation event has receded. And the vegetation can then use that over time for maybe months or possibly a year or so after that event. So increased evapotranspiration by deep-rooted vegetation is one of the benefits of the project, and we expect that to occur over time. There is also increased groundwater return flow to waterways. Again, near the Murray River in particular, where the groundwater level is closer to the river after a major flow event or a flood, groundwater level being a little higher, when the river level drops relatively rapidly, usually over days to weeks, the groundwater takes a little longer to respond, and there is a period in which groundwater will naturally flow back out into the river. Mostly it's returning that river water that might have been into it during the flood event. But an effect of these projects is that process will occur after a managed event, and there will be a slight increase in the amount of groundwater that flows back into the Murray River in particular. But in some of the shallow waterways, you may see a small response into those waterways afterwards. But most of the effect here will be groundwater returning back into the Murray River. We do not have any reason to believe that there is a change in groundwater quality that will result. The process of taking river water, having it on the floodplain, and then either evaporating or running off is exactly the process that occurs at the moment under natural floods. It's a process that's occurred in the pre-regulation regime. You were talking about that content earlier, what happened prior to river regulation and then during the regulated river. This is exactly the same physical process occurred. There is no reason to believe that the water quality will change as a result of the projects, bringing that water onto the system. Also, a comment that after the documents were exhibited, we did an update to the groundwater modelling. The groundwater modelling was updated for two reasons. In the exhibited version, the maximum extent of the inundation, what's referred to as the MIE, the modelled inundation extent, was slightly different in the exhibited documents from what had been assessed in the groundwater modelling. That was generally slightly smaller. Also, since the work had been done for the assessment, we had that major flood event in 22-23. So two changes were made. We adjusted the groundwater modelling so that the recharge or the effect of the area lined up with the MIE, and we also extended it so that it included the effect of that larger flood event in model assessments. This did not significantly change the findings in the model. There were some differences as a result of those changes, and the additional modelling shows a closer match to the project as it's intended, but has not changed the assessment or the conclusions of the original model.
That, Mr. Oxley, is the work reported in the further technical report.
That's right.
Revised groundwater modelling, document 35A.
That's right, and all bound up with my statement. Yes. So to talk a little bit about where groundwater is present, and we'll start with the Gunbower project. There are a series of layers of sediment underneath the ground, that layered formations that occur under the project area. And for the purposes of the project, it's really only the upper layers that interact with inundation. Whilst there is groundwater present in all the layers down to 100 to 150 metres below the surface, the floodplain is essentially the uppermost 10 metres to 15 metres or so. And as shown in the diagrams on the right-hand side here, this is the Coonabidgel formation. It's called the Coonabidgel formation. These are sediments that are associated with from the deposition of the Murray and from floods over geological time, so over tens of thousands of years. Under that are a couple of other units called the Shepparton Formation, and then beneath that is another unit that's called the Culliver Formation. It's also sometimes referred to as the Deep Lead. There is other pumping and irrigation use out of the Deep Lead, but because of the nature of the Shepparton Formation being mostly clay and limits the amount of interaction between the surface and the deeper units, essentially the surface units that are in connection with the river and the floodplain are essentially hydraulically isolated from the deeper Culliver Formation in this area. So for the purposes of looking at assessments, the projects really only have an impact on that water table, shallow groundwater, and those top 10 metres or so of sediments. Groundwater in these sediments is influenced by rainfall recharge, by river levels, adjacent waterways, and also adjacent land use. So outside of the floodplain areas, the groundwater level is affected by land use, and it's particularly around irrigation. So you have irrigation plots outside of the floodplain. They receive regular watering. The groundwater levels in those areas are a bit high because of that regular irrigation recharge. I just make the point here that effectively they water over the irrigation season every few weeks over the irrigation season, and water levels are a little bit higher. That is a similar process to what will happen in the floodplain, but the flooding occurs for a few weeks every few years rather than every few weeks, which is why the water table in the forest area is a bit deeper, and we're not expecting a response of the same magnitude as you see underneath the irrigation areas. So groundwater is typically deeper below the surface in the project areas than outside for the reasons of irrigation, and also the forest in the floodplain area and that tree water use draws down the water table and soaks up the water that's in those areas. So the vegetation has access to the water and brings it up. Next, a couple of maps here illustrate what we understand about the water table elevation and the depth of the water table. So again, these concepts that I mentioned earlier. The contour map on the left-hand side here shows the water table elevation, that is the height above sea level. And the main things to draw from here is that there is generally a higher water level to the south around Gunbower and outside of the project areas, and it flows to the north and towards the river. On the left-hand side, that's the purple lines on the left-hand side. I may have said right side before, sorry about that. That's the lines on the contour lines on the left-hand side. On the right-hand side, we have a coloured map that shows different colour bands of the depth to water table. Throughout the project area, which is shown with the more fluorescent green areas close to the river is the MIE, we see that the water table depth is typically 5 to 10 metres below the surface. Then as you get further and further away from the Murray River, say around Gunbower Creek, you're in a region of say 2 to 5 metres depth to water table, and then out near Gow Swamp, it gets quite shallower and it can be less than 2 metres below surface in some of those areas. So the key point here is that we have deeper groundwater levels near the river, which corresponds to a flow gradient generally towards the river, but that under the project area, the water table are up to 10 metres deep. How do we know this? There are a number of groundwater wells and boreholes that have been drilled around the area. This figure here, which shows a number of the locations of different groundwater wells and information that we can use to build up that groundwater picture. It also shows a number of the sites here, which are the red dots with the black in the circle and numbers next to them. They are locations where we have groundwater monitoring that are really close to the project areas inside the forests. And they've been quite instructive in telling what the groundwater depths are and the way that it responds to river fluctuations. And you can see the light blue areas of the maximum modelled inundation area, the MIE, or for the different water management areas that was being talked about and is the core of the project area. Shallow groundwater in this region, as we understand from that monitoring, has a muted response to river level changes. The chart here shows on the groundwater levels compared to river levels. So there's a line across the bottom here, which is in blue, which is showing lots of spiky peaks, and then run along it, that is the Murray River level from 1990 onwards. And then there's 3 lines across the page here that show different groundwater level depths. The lines going from the top to the bottom are the shallowest going down to the deepest. And so you can see that at 20 metres depth, the borehole, which is numbered 87809 at 20 metres depth, has got a water level that was generally higher through the 90s. It then drops through 2000s, through the millennium drought, and has been sitting at a level of about 83 metres above sea level, mostly throughout the last 10 or so years. There's a slight rise in recent years, in 23-24, as a result of the very large floods that went through. So the key point or context that I wanted to make about putting this slide in is we talked about that residual effect of the project. So after the effect of the project being put in, there will be a slight increase in groundwater levels. I want to put that in the context here. If you go back to, say, 1995, when the groundwater levels underneath the project area were typically around 85 metres, we're now at a situation where they're 2 or 3 metres lower than that. So if we have a small rise in groundwater as a result of the implementation of the project, that is still, the rise that we're expecting is still below the level that we would have seen in the 90s, and going further back in the wetter periods back through the 70s, likely to have been even higher than that. So in context, while there is a rise, it's actually taking it closer back to the conditions prior to the millennium drought and prior to the strong effects of river regulation and taking water out of the river. So it is would not be experiencing an effect that is outside the range that has typically been seen under historical conditions. Talking about groundwater quality. Groundwater quality in this area, we mostly refer to it in terms of salinity. So this map here that I've got on the screen shows groundwater salinity, or total dissolved solids, with the colours grading from blue colours along the river out to the orangey colours further away. Outside of Gunbower Creek and outside of the project, you can get quite saline groundwater. It's between, say, 20 to 35,000 milligrams per litre TDS. For contrast, Seawater salinity is about 35,000 milligrams per litre. So out in those areas, well outside the project area, inside the irrigation areas, we have relatively shallow water table, maybe 2 or 3 metres below the surface, at a salinity that is around that of seawater. You will see in some of the submitters' commentary about the project that they refer to high groundwater, shallow groundwater and very hypersaline groundwater. We know about these effects. They are outside of the main effect of the projects. The projects themselves are in much fresher groundwater, typically 3,000 to 5,000. Again, this sort of salinity or quality of groundwater is readily accessible by vegetation. Box trees will use up to about 20,000 TDS, 15 to 20,000 TDS. Reed gum prefer it slightly fresher. And the groundwater that's underneath the project areas is typically within the water quality range of being able to be used by vegetation. As I also said earlier, we are not expecting this to change as a result of the project. Bringing fresh river water in, allowing a little bit of seepage into the soil and some of that to go into groundwater with regular pulsing of that type of flushing will not increase the salinity in this area, and we're not expecting any change to groundwater as a result of the projects. I'd like to move now to the effect of construction. There are, for the Gunbower project as well, there are some works that might possibly intersect or affect groundwater. The river track regulator, Cameron's Mid Creek regulator, Mid Gunbower pump station and Spur Creek forest drop structure. Now these structures have got a combination of they're slightly bigger, they have to go slightly deeper into the ground, and also they're typically on or adjacent to a waterway. So where you have slightly shallower groundwater because it's more connected to a waterway and a slightly deeper structure, there's the potential that the bottoms of these excavations might intersect groundwater. We have assumed that they will intersect groundwater, and we've assumed that there will need to be some dewatering to keep that as excavations dry whilst the construction is going on. We've looked at the effect of between 6 months to 12 months worth of dewatering to lower the water table a bit. It may only be a metre or a metre and a half, but there will need to be a little bit of dewatering. It is possible that you could use other construction techniques, things like SIAC piles and so on, that could eliminate the need for dewatering. We've assumed sort of standard industry techniques of maybe a sheet pile walling with dewatering for this. If it turned out that these drawdown effects were unwanted, there are other alternatives that could eliminate them. But assuming that they go ahead in that way, there may be dewatering required for up to 6 months, which will lower the water table a little bit in the immediate vicinity of the structures. We expect that will be in the order of 500 to 800 metres away from the structure. Because they're also on waterways, and the waterways have the potential to bring water back in response to the drawdown, there's this natural sort of buffering effect of that you can induce flow in from waterways. But what you might see is that some of the vegetation within a couple of 100 metres of these structures might have slightly lower groundwater levels for the period of dewatering of maybe 6 months to a year. It is possible, depending on the conditions at the time, if it's a particularly dry period, it may be no dewatering is required, or there will be very little effect on vegetation. The groundwater is relatively fresh. It could most likely be disposed of by putting back into the river, or as a possibility, if it's needed, it could be used to irrigate or supplementally water any trees that might be affected by the drawdown current. Again, if that was too difficult to manage, you could use SIAC piles or some other grouting technique to completely eliminate the need for a broad-scale dewatering. But in any effect, this is a minor effect. There are a number of structures that have been built along the Murray River or upgraded over the years that have seen this type of thing go on. So this is not a major effect, it's what you call minor to insignificant effect. In terms of commissioning and operation, managed inundation effectively causes water to infiltrate into the soil. You're going to see a slight rise in groundwater following an event. The vegetation will then use that water, it will drop back down again. And overall, there's likely to be a small cumulative increase over time. We don't expect the quality to change, but we do expect a little bit of that groundwater to flow back into the Murray River after the events or after the water table is slightly higher. So there will be a very slight increase in the salt load in the Murray River because that groundwater, although relatively fresh, still carries salts and it will come back into the Murray River. So compared to a no project baseline, there is a small increase in salt. For the Gunbower project, it's essentially negligible. It is a really, really tiny effect on that. It's not accountable under the Murray-Darling Basin Salinity and Drainage Strategy. Got some figures that are taken out of the assessment report that show the percentage of time that shallow water tables will be shallower, and typically about 5 to 10% of the time underneath the core of the MIE, we will see some increase in shallow water table. On this map, there is also shown some areas that are where the water table is already quite shallow around Gunbower Creek. Whether or not these occur is a function of the water conditions at the time and the extent to which there are flows down Gunbower Creek going on. For the groundwater model, here we've adopted a conservative approach that assumes that Gunbower Creek has more water in it and is also moving up and down. That does not necessarily have to happen with an event and may actually not happen at all. We put comments about mitigation and observing these areas in the reports. These are not significant effects. Simply because the groundwater is shallow does not necessarily mean that those areas will go saline, and it's unclear that these are necessarily going to occur. We just identified them as a risk, a possibility, and have put some recommendations about monitoring for those people. The other change is the change in vegetation water use, and these maps show the slight increase in ET expected. Wherever you have deep-rooted vegetation, we're expecting to see slight effect.
ET is evapotranspiration.
Say again?
ET is
Evapotranspiration.
Yes.
Evaporation and transpiration, which we
yes.
Transpiration. That's it. And I also mentioned the slight increase in salt load to the Murray River. Conclusions for Gunbower. Look, I think I've been through this, so I'm not going to read this slide out again. They're basically more water in, a bit more water out. Now I'm going to talk to Guttram and Benwell. I'm going to go through this one a little faster than I went for Gunbower because, as I said at the start, the impacts and the effects are quite similar. Guttram and Benwell are slightly smaller areas. There is one point that I'd like to make about the subsurface conditions for this area that's worth noting. There is more of a clay sequence. This lower Shepparton formation, what's here known as the Yando clay, further separates the Cullival or deeper aquifers here from the Coonambilgil and the upper Shepparton. There is even less connection for Guttram and Benwell than there is for Gunbower. And so again, the effect though is that we really only need to look at the surface sediments to look at the change from knowledge. The effects are because of where the Murray River is and the Coonambilgil formation. I've got a bit of a cartoon diagram here that shows at the Murray River, you've got the groundwater level and water table, which is shown by that top blue line connected to the Murray River. And then there's a bit of a dip as you go underneath that because the forests are taking water out of the groundwater system. And what we see is that there's a bit of a hollow or a depressed area of groundwater level through those forests. That's shown in the diagram on the left here, which again shows groundwater contours of level. And you can see there are some circles there where you've got what look like contours circling around each other. There's some places where we've got quite deep groundwater, which we believe is the result of the vegetation taking the water. Groundwater quality is fairly similar. Again, when you're outside of the project areas, there is more saline groundwater, but inside the project areas, it's pretty fresh. And the water table depth is typically 5 to 10 metre range underneath these forests. Groundwater levels follow river levels again. These are some nearby shallow groundwater bores with the bore numbers shown up the top and then the lines showing their elevations ranging from 74 through to 76 metres. I think the key context that I want to show here is that over time from the 1970s, we had a peak in groundwater levels up at say 76 or 77, dropping down again through the millennium drought, a lower period, and then relatively high response after the large floods of 22, 23. And I would expect that unless we get another large flood like that, they will start to drop away again consistent with the pattern that we've got of rising and falling. The projects will add a little bit to this overall rise and fall pattern. Plot on the left here shows the locations of the bores which we've used to build up the groundwater understanding of the area. And the coloured chart on the right shows groundwater salinity around the project area, with the more saline groundwater again up to seawater salinity around the southwest, and fresher less than 10,000 milligram per litre TDS closer to the river and under the forests. There are 7 structures within these projects that might require dewatering because they're either closer to the Murray or in areas of slightly shallower water table closer to irrigated areas. About, again, between 6 months to a year of dewatering required depending on the exact construction schedule. And as with Gunbower, a slight or minor lowering of water table within a few hundred metres of these sites, depending on the groundwater conditions at the start of construction. With groundwater disposal to waterways, or if there are particularly significant trees that need to be supported, it could be used for irrigation as well. Again, in terms of commissioning and operation, we're expecting groundwater levels to be slightly rise as a result of the project inundation. Remembering this is on the case of generally lower groundwater levels within the forested areas. Once again, following inundation, vegetation will use the soil moisture, the groundwater will drop away. Over time though, if the project's able to be implemented to the desired ultimate frequency, we would expect that the groundwater levels come up a little bit. Depending on whether or not they actually achieve that extent of inundation may mean that they could be about the same or they could be slightly higher. Groundwater quality is not expected to change, and there will be some flow back into the water courses. Here at Guttram and Benmore, because they are right on the river, much closer to it, there is slightly more salt that gets back into the river than it is for the Gunbower project, where the MIE or the management areas are slightly set back from the river. So there is a bit more expected response from groundwater coming back into the river here. Again, not significant in terms of the salinity and drainage strategy. The amount that is going into the river is not expected to be accountable under that strategy, but it will be a very, very, very small increase in the river, right on the edge of being measurable, actually, really small change. But it's been allowed for and is expected to be a small increase in salt load. Equivalent plots for Gunbower showing the percentage of change in water table. This area will see, after the larger events in particular, water table will come closer to the surface for a while and then drop away. At the moment, because these forests are not getting that degree of inundation, it's not coming up quite as high. So what this is showing is that the proposed project will really bring the water levels back to being able to rise and fall, and you will get more periods of shallow water table, which again is part of the purpose of this, is to get soil moisture up so the vegetation can have access to it. That's going to result in increased ET. This particular plot again showing some relatively modest good increases in ET. Whilst it's a nice bright red here, it's about 50 millimetres a year in increased in evapotranspiration, which is a modest effect. Worthwhile doing, but not a very, very large change. Salt load return to the Murray. Got a chart here that shows from the models the expected salt load return. Key difference here between the green line and the orange line, that you'll see that after a number of the events we're expecting slightly higher pulses of salt coming back in. They typically last in the order of a month or two after the event. Through this period in the area of, say, 2012 to 2016, where there were a series of higher rivers, there would be a bit more salt coming back in. So it's not all the time, it's really only after the more significant events, or if we go through a wetter period where we're having higher groundwater levels. We've emphasised that this is essentially a negligible effect. Overall conclusions: insignificant to minor changes in groundwater processes, slight rise in groundwater levels, in change pattern of rising falling groundwater level to be maintained with slightly higher peaks, increased evaporation and increased return flow to the Murray River, which will mobilise a small amount of salt back into the Murray River. And it ends the section on the assessment report and the analysis that we've done. I want to talk briefly about the submissions. The EPA suggested some changes to EDS-CM2, looking at monitoring for indicators of oxidation for acid sulfate soils. Just really note that this risk is only really likely during drawdown, during construction, but nevertheless, I agree with the changes of monitoring and wherever it's thought to be a potential risk. The EPA also recommends a change to MGW2 so that monitoring of groundwater quality would be undertaken. In the wording of the EDS, we talked around groundwater salinity. In their assessment report, we put in a table that had a number of groundwater quality parameters. This is table 13.3. And although the EDS said salinity, there was actually a recommendation to do a range of quality parameters. So I think the EPA's recommendation to change the EDS to talk about quality is totally in keeping with the assessment report. And in terms of what quality parameters to assess, I believe that table 13.3 identifies those water quality parameters. So if there's to be water quality monitoring, I would refer you to table 13.3 for the recommended parameters to pick up as part of that monitoring. So the EPA again referred to monitoring contaminants of potential concern. From my point of view, I take the contaminants, I use that word loosely, but contaminants of potential concern or the parameters that you need to look at are listed in table 13.3.
Just to be clear, Mr. Oxley, I think you've identified this on your slide, but you've had the opportunity to review the day one version of the SIAC and the monitoring requirements. And I understand it to be your view that the changes made in the day one documents reflect the EPA.
That's correct. I'm happy with that. Yes. Another comment referred to the presence of high salinity groundwater in the area. As I've talked about, salinity is variable. Of course, the project is high salinity groundwater to the south or southwest of the sites. There's general comments like this particular submitter suggests that the effect of holding water on the floodplain is unknown. I don't really agree with this because we've got groundwater monitoring. We've seen the result of natural floods. We know what the effect of holding water on the floodplain is, how that's going into the ground. I think we do have a sufficient understanding of floodplain dynamics and the way the groundwater responds to be able to make that assessment and conclude that it's a reasonable thing to do. I understand the concern, but I'm not sure that the submitter's actually looked at that groundwater information to the depth that we have and is fully aware of it in making that comment, perhaps. There's also a comment about adverse effects on red gum trees at Red Rise Swamp. The only comment I wanted to make about that was that the groundwater elevation we believe to be at about 75 or 76 metres HD there. I've got those put in my presentation. Surface elevation of 85 metres, that looks about right to me, looking at the LiDAR and the other information. In which case, we've got a depth to water table of 10 metres below the surface there. It seems really unlikely that shallow groundwater is driving the vegetation response that they're attributing to it. So I think the comment from the submitter was saying, oh, we're seeing vegetation behaviour or die-off that we think is inappropriate. We're calling out shallow groundwater. What I'm saying here is there's no indication of shallow groundwater there, so that might be the vegetation response, but I don't think it's related to groundwater. And there's another point in submission 20 about reference to referral documents or not looking at certain things. It wasn't clear to me that the submitter actually looked at the specialist assessment. It's my view that the queries about things having not been done is actually exactly what we've done in the assessment document. I think this is looking at the referral, so there might have been a gap in the information that the submitter was looking at. I put to you that the assessment document we put together actually directly addresses the things that submitter was concerned hadn't been addressed. I won't read this out, but basically what I was saying was that the day one documents, I think, characterise the changes that were recommended, and I'm comfortable with the day one documents and the changes to the EDS that are in there. And that concludes my presentation.
Thank you. I'm going to ask you just a couple of questions on that last theme in terms of monitoring requirements. And to take over the screen from you.
Yep.
I think I've done. Please stop on those screens. I'm sharing the day one monitoring requirements, document 51 and page 3. I'm zoomed right in on what is MGW1.
Yes.
And that relates to groundwater level monitoring.
Yes.
And as I scroll across to the right, we see the indicator and requirements and parameters and so on. And then in the locations column, lists of a number of bores for Guttram and Benwell, and then a number of bores for Gunbower.
Yes.
Now I understand in the specialist assessment, you identified the appropriate bores for monitoring. And in your presentation, you've included a couple of figures showing bores around the project areas and, I should say, around the study areas and inside the inundation extent that's been modelled. Yeah, that's fair.
So all of those bores are identified in the special assessment as to where they are and their relationship to the MIE. Yes.
In respect of your response to submission, I think it was 9, you referred to the knowledge we have in terms of salinity. I'd just like to ask you for your view in terms of the adequacy of these sets of monitoring bores in terms of an understanding of groundwater levels over time.
Yes, there's a number of bores that are listed here of various ages that have been around times. A number of them have been put in particular by the North Central CMA specifically for these projects to monitor groundwater level around the area. I'm quite happy with the bore locations and the spread of information here, and they really picks up on using the North Central CMA bores. There's a couple of reasons why I'm comfortable with this. One is that overall, the risk posed to groundwater by these projects is quite low. It doesn't need super detailed bores in a large number of areas across very fine resolution. There are a series of bores that capture the groundwater levels around the project areas that are good for picking up the overall groundwater response. It is problematic to go and put bores specifically inside the MIE or right in the middle of flooded areas. The reason for that is they get flooded and so you can't get at them. There's a risk that the flooding will actually flow back down the bore and interfere with the readings. And so the idea of having bores that are close to the MIE but not necessarily inside it to enable you to see the groundwater response more generally around the project areas, I'm really comfortable with. Operationally, it makes sense. You can put the bores on tracks and in places that you can get at more readily, and you don't have to go into and put disturbance inside the forested areas to actually put the bores in. So having regard for all of that, the nature of the existing bores, where they are and what's available, and the general low risk that's posed by these projects, I'm comfortable with those locations.
And you started by talking about that in the context of our existing knowledge over decades. Does your comfort extend in terms of using these bores for monitoring going forward?
Yes.
Right, and that's MGW1 for levels and similar requirement GW2 for quality, subject to those day one changes you referred to.
That's right.
Do you have any differing observations in terms of salinity monitoring that was nominated here?
No, and I think substituting salinity for quality and noting that again, table 13.3 identifies what it means. It makes sense to monitor the quality at the places that you're also monitoring the level, because you can tie in the fluctuations of groundwater level to any quality changes. Also, as they generally surround the project areas, they would show it if it was to change around and outside of the project areas. And again, the practicality of putting in new sites right in the middle of regularly flooded areas is quite difficult and operationally challenging. So there doesn't seem to be a really strong case here for doing that. There's no particular critical decision that has to be made on the result of water quality immediately right underneath these sites. It's a general, we're not expecting any changes. This is a background surveillance to basically confirm that that condition is being met, and provided that there are no changes, then I think I even suggest that undertaking a review after the second maximum event, and if there's no changes or it's behaving as would be expected, you may be able to scale back on the level suggested here.
I think I inadvertently led Mr. Hoxley to my next question by zooming in on that column on the screen. Mr. Hoxley, I'm asking you these questions but you also gave evidence in respect of previous packages to ES Central, and You might recall there was discussion in that context of a need for additional bores.
Yes.
What's your view in terms of that in the context of the ER East project?
Yeah, I come back to the risks that the project poses to groundwater. Each of the project packages has different risks, and just as a general context, the further downstream you go or down basin you go, the groundwater gets a bit more saline. The landscape changes, the nature of the connection to the river changes, and there's a different risk profile overall. So certainly as you go towards the west, it's a bit different from what it is in the east. We're dealing with an area that's got reasonably good existing information, is relatively fresh groundwater, is relatively modest inundation events compared to the natural events that occur, and is not expected to result in significant changes. So I'm comfortable with the level of bores here. I could see why in some other places where the historical record was not as good, or we didn't have the data loggers for that period of time, that some additional information could have been warranted. I don't think that applies in this case. I'm quite comfortable with using the existing bores and having monitoring at those sites for quality and level.
Thanks, Mr. Oxley. Thank you, Member McMillan. I think it was worth taking those extra few minutes. I'm not noting the time. That's the evidence in chief.
That's fine, thank you. It's only 6 minutes over, so it's okay.
Yeah, your answers to Mr. Forrester's questions covered most of what I was going to ask about the bores. But I was just wondering about how you propose the monitoring close to the construction site during the construction period in terms of the groundwater levels.
Well, this will be part of the detailed construction environment management plan and will need to be built up based on the actual construction methodology. I would expect that there would, if dewatering is required and is expected to have an effect on groundwater, then there will be monitoring bores that will be put in place around or nearby the site, likely within the construction footprint that will be used. They would probably need some type of surveillance to make sure that they were achieving the level of drawdown to keep the site safe. You would use the same monitoring bores to see the effect of the drawdown cone. So in essence, it would be part of the construction works and would be necessary for construction. And as such, it hasn't been determined yet because I haven't done the detailed construction descriptions.
Thank you. And then my second question is, what would be the mechanism for the salt to increase above what's been modelled if that was to occur?
There's really difficult to see how that would happen to any great extent. Either you would need to bring in much more salt with the water that was coming in, which we're not expecting river water to that extent. The only other reasons why salt is concentrated in the landscape is if you have shallow groundwater where vegetation is able to concentrate salts by extracting water and the groundwater stays shallow. If groundwater were to remain shallow and there were to be continual withdrawal of water, leaving salts behind, salinity could rise in the soils. Again, because we're expecting the groundwater levels to drop down and for succession events to move the water table up and down, we're not expecting the water table to stay shallow for long periods of time, which means that we don't believe that mechanism is going to occur. But in theory, if a shallow water table were persistent, there to be consistent evaporation off that water table, the groundwater salinity could increase in those areas of shallow water table.
And when you say shallow water table, what sort of?
Typically, the risk zone for that would be where it's less than 2 metres from surface. So closer than 2 metres to the surface.
I'll just officially close out the same question from the Friends of the Koala. I think you were here and heard Mr. O'Farrell's response, but just checking.
No, I have nothing to.
Yeah, okay, good. Thank you. Thanks for your time.
Thank you. If Mr. Oxley can be excused.
Yes, no problem.
Thank you.
Have a 15-minute break now, so I'll come back at 5. And if the next witness, I think it was Mr. Treadwell, get set up, we can go from there. Thank you.
Thank you.
Years ago, they had an infestation. Keep warm.
Testing for the online people that they can hear okay.
Yes, we can hear you online. Thank you.
Thank you. All right, we're ready to hear from Treadwell, so thanks for getting set up.
Thanks, Dr. Treadwell. I think you've got a presentation there, but in terms of the witness statement and the set of slides that you prepared, is there anything that those two documents that you wanted to add, subtract or correct?
No.
You adopt both of those documents as true reflections of your opinions in this matter?
Yes.
Into those, please. And I think you've been here this morning, you understand the format, so can I pass across to you?
Let me just share my screen. Got the right presentation up. Thank you. I'm here to talk about the surface water assessment for the Gunbower and Gutchman Bend.
The Treadwell, if you could, we've got some amplification in the room, but if you could keep your voice up. Being with a bit of a rattle.
So for my presentation, I'm going to provide a summary of the work undertaken, an overview of the existing conditions, potential project effects as they relate to water quality and other surface water impacts, the response to the relevant submissions, and comment on the proposed environmental delivery standards. I was responsible for the preparation of the Specialist Assessment C surface water. I planned and coordinated the technical assessments of surface water effects, along with other specialists as outlined in my expert witness statement. I co-authored the Specialist Assessment along with contributions from those other specialists as noted. I just wanted to talk briefly about what surface water effects are. So in terms of the assessment, they relate to floodplain hydrology and hydraulics, the movement of water over the floodplain, risks to erosion from that water movement, changes in depth and velocity of water on the floodplain as a result of project infrastructure and project operation, and also water quality. There are obviously elements of surface water characteristics that then have flow-on effects, so to speak, to ecology and other related benefits and impacts, and they're dealt with by other witnesses, and you'll hear from those later in the week. I've reviewed the public submissions and prepared responses relevant to surface water effects. I've reviewed the SIAC directions and prepared relevant responses to those, and I've prepared an expert witness statement upon which this presentation is based. I'll just talk briefly about existing conditions. The project areas contain, and I apologise that you have heard some of this before from the CMA and also from Mr. Tate earlier this morning. I'll whiz through them as quick as I can. The project areas contain waterways, wetlands and floodplains that support water-dependent flora and fauna, and also ecosystem processes that underpin riverine food webs, such as carbon and nutrient cycling, that are also reliant on inundation and the associated process of wetting and drying. So we're not talking inundation and leave it wet all the time. The process of inundation, wetting, and then periods of dry contribute to the processing of organic material and nutrients, and that's an important outcome or benefit of floodplain inundation, natural or managed. Prior to river regulation, lower elevation parts of these floodplains would have received inundation in most years, the parts closest to the river, and higher areas of elevation would have also received inundation, although not in all years, depending on climate conditions and river flow. So you get this varied range of inundation depths and duration frequencies as you move predominantly from the river away to the edge of the floodplain and the ground elevation increases. But as we've heard from others, the results of water resource development and river regulation has seen a reduction in the frequency and duration of Murray River flow thresholds that relate to these inundation extents. And levees and other structures are also present on the floodplain now that influence flow paths. And then looking forward, climate change is likely to lead to further reduction in the frequency and duration of unregulated river flows. That's not to say that floods won't happen in the future, but with the predictions from climate change, the frequency and the duration of some of those events will change, and that has an impact on floodplains as well. So on to potential project effects. I'll talk first about construction and then move on to operational effects. Construction, any type of construction, has the potential to result in adverse water quality effects to surface waters. And this includes erosion and runoff from disturbed areas, creating increased turbidity and sedimentation of waterways, exposure of contamination or acid sulfate soils during excavation, contamination of surface waters as a result of construction activities and accidental spills. And as you heard earlier from Mr. Hopsley, the discharge of groundwater to waterways if dewatering of construction sites is required. So these are common, risks associated with construction wherever you go. But when you're on a floodplain where there's water bodies around and waterways crossing the floodplain, there's obviously an increased risk that construction-related effects can make their way into the waterways, particularly if they're flowing at the time of construction. Having said that, the environmental delivery standards have been developed to manage and mitigate potential construction adverse effects, and this includes the development and implementation of a construction environment management plan, and there are impact-specific EDSs. Collectively, with the implementation of those, we believe the residual adverse effects to surface water values from construction is low. So all of the construction-related effects are well understood and they're manageable with existing techniques for sediment control, site management. I'll now move on to operational effects. So first I'm going to talk about operational effects in terms of depth and extent of inundation during unregulated floods. And I think it's important to make the distinction between project effects under normal, non-managed water conditions, so unregulated conditions we call it, and when actual managed inundation is occurring. You heard from Mr. Tate earlier this morning about the hydraulic modelling that's been undertaken. We've based our assessments on the outcome of that hydraulic modelling. We believe that hydraulic modelling is appropriate for the purposes. That hydraulic modelling gave us information on depths, extent of inundation and velocities and other, or those kind of hydraulic characteristics of water on the floodplain. And that modelling modelled conditions as they stand at the moment with existing infrastructure in place, and they also modelled conditions with the proposed infrastructure in place and with that infrastructure in different operational modes. So first I'll talk about what happens during unregulated floods with the infrastructure in place, but with those regulators all open. So effectively they're set to a default position where they're designed to limit any hindrance of water movement on the landscape. And so during unregulated floods, as the water level increases in the river and it spills onto the floodplain and it progressively rises, water flows through those open regulators and culverts in a very similar way to current. And you heard from Mr. Tate that there is, however, some afflux where there's an increase in water level in some parts of the forests as a result of that infrastructure. And the modelling indicates that there's potential for that afflux or that higher water level to exceed the height of forest levees in the Gunbower area and potentially create some localised inundation outside of the forest at a flow that is lower than would currently occur And so that's not to say that these locations outside of the forest would never be inundated. It's just that they're possibly potentially inundated at a flow slightly lower than what would currently occur. So if a flood continued to rise, then those areas would become inundated anyway, according to the model. And there's a number of reasons for why this could occur. There could be some variations in the understanding of the levee heights in those areas, and there's also potential for, I guess, some uncertainty in model outcomes and the models the best representation as possible, but they, like everything, have some variation in their certainty. Having said that, there's an EDS in place, EDS SW4, that will ensure that any land outside of the forest, any private land or inundation of that land, would be managed through revisions to infrastructure design and, if necessary, appropriate landholder agreements, such that that effect is mitigated. It's worth noting that during the 2022 floods, some of the levees were raised and repaired in certain areas that align with where some of this modelling is indicating that potential flow outside of the forest. And it's quite possible that that effect has already been mitigated now. The maps that I'm showing on the screen are there to highlight that the majority of the forest areas, and this is for the Gunbower example, are experiencing depth distributions that are very similar between current and proposed conditions. Like, there's no depth difference, and that's the vast majority of the pale yellow area across the majority of the mapping. During managed inundation, we see the modelling is able to show us the depth and extent of inundation with the infrastructure in place, and then operated to deliver water to particular parts of the floodplain. And these maps are showing the inundation extent for Gunbower Forest. And again, Mr. Tate talked you through the various water management areas for Gunbower, and also for Benwell and Guttram forests. And you can see that the managed inundation area for Gunbower is relatively small compared to the majority of the forest, whereas for Benwell and Guttram, the managed inundation extent, or the modelled inundation extent, represents a much larger proportion of the forest. So the infrastructure is able to deliver water to large areas of those forests. Importantly, during managed inundation, water is fully retained within forest perimeter levees. And the colour coding on those maps shows the different depths that can be achieved. Inundation to the largest extent possible with the infrastructure. It's worth noting that on not every occasion of managed inundation would inundation occur to the largest possible extent. So there are watering scenarios where smaller areas of forest would be targeted. And a good example here would be in Guttram and Benwell forests. The orange is showing slightly deeper wetland areas, and those wetland areas could be potentially targeted for more frequent managed inundation, and the inundation can be confined just to those areas. And then on other less frequent occasions, the entire modelled inundation extent could be inundated. So we're not seeing managed inundation to the entire extent on every single occasion. I'll move on now to velocity and shear stress. So velocity is the speed at which water moves over the landscape. Shear stress is a calculation based on the velocity and the gradient of the water surface. And the higher the shear stress, the greater the risk of erosion occurring. And so obviously we don't want to create conditions that are outside of the normal processes that are occurring on floodplains during flood events. The maps on the left show the difference in velocity between current conditions and future conditions with the proposed infrastructure in place during a large flood event. And essentially, there is no difference in the distribution of shear stresses and velocities across the floodplain between current and proposed conditions. So we're not seeing an increased risk of erosion at a broad scale in relation to the projects. And I've only shown it for the Gunbow here, but the same applies for gut tribunal. However, during managed inundation, and in particular the release of water to downstream areas, either during inundation or at the end of inundation when water is released through downstream regulators, there are some localised increases in velocity and shear stress downstream of some regulators. These have been identified and they'll be managed through appropriate regulator design and operation, and in particular EDS GS1 is related to detailed design, and EDS GS3 and SW2 are related to operations, and they provide for the mechanism to double check the location of and the design of regulators, look at where there might be a risk of erosion or increased shear stress downstream of those regulators and include appropriate design. It could be rock beaching or some other design element. And then during operation, the rate at which those regulators are opened and closed can also then be used to manage the speed at which water leaves or passes through those structures. And in that, manage the potential risk. I'll move on to water quality effects. The main water quality effect we see with inundation of floodplains is in relation to dissolved oxygen. I do have a slide a little further on in response to submissions, but I'll talk to it now in terms of the process for dissolved oxygen declines during inundation. So when the floodplains are in dry condition, leaves and bark and twigs and things all fall onto the floodplain, grasses grow and that material accumulates. When it's inundated, that material starts to break down by bacteria and fungi, and that process of breaking down that material consumes dissolved oxygen that's in the water column. And in severe cases, that decomposition can cause the dissolved oxygen to decline to low levels, and we call it hypoxic if it's below 2 milligrams per litre and anoxic if it's 0 milligrams per litre. Fish start to get infected around 4 milligrams per litre, so if we're down at 2 and certainly at 0, then there's potential impacts for fish. But this is a natural process that occurs when organic matter is inundated. And what we've seen on occasions during very large flood events where the whole of the floodplain's inundated in large flood events like in 2022, we get a large decrease in dissolved oxygen, and that can flow on into what's termed a black water event, and that leads to fish kills in the river because there is so much organic material that's being inundated and deoxygenated water coming into the river. You need very, very large floods of large parts of the floodplain in order to experience those kinds of fish kill events. And I should point out, it's worth pointing out that the term black water is used to describe the colour of the water because the tannins from the vegetation leaches into the water column, gives it a black appearance. Just because it looks black doesn't mean the DO has declined. So I prefer to talk to it in the context of hypoxic and anoxia rather than black water, because black water implies that, that there's low DO. That's not necessarily the case. During a managed inundation, there is the potential, as water moves onto the floodplain or is put on the floodplain, particularly if the floodplain's been dry, that there will be a decline in dissolved oxygen on parts of the floodplain. And the maps on the left show a sequence of inundation, Guttram and Benwell. The blue might be a little hard to see, but progressively as the floodplain inundates, we've got blue, fresh blue water moving onto the floodplain. And then fairly quickly though, once the floodplain is inundated, you can see the red colour, and that's indicating that we are having areas with low dissolved oxygen. That persists for a period of time, but as fresh flows and what we term through flow continues to come onto the floodplain, it provides dilution to that poorer quality water. And so during the inundation event, and certainly by the end of the event, the dissolved oxygen has been replenished in effect through a combination of bringing fresh water onto the floodplain during the event, that water mixing and flowing through the water that's on the floodplain, and also other processes. The organic material gets decomposed, and so the drawdown or the rate of DO decline gets less. And there's also re-aeration through the surface of the water, and that brings in dissolved oxygen into the water column as well. So we do get this dissolved oxygen decline. It can get quite low, but it is also mitigated to some extent through flow. Again, that's a natural process. It happens when floodplains are inundated. And it particularly happens when floodplains haven't been inundated for a long period of time because there's a larger amount of accumulated organic material. The more often floodplains are inundated, potentially the less accumulated organic material there is, and so the severity of dissolved oxygen decline may be less. There is a flip side to that. If floodplains are being inundated more often, they might produce more growth, and so you could have increased organic matter and leaf fall and things like that. So there's a balancing act. But in general, the very serious black water or low dissolved oxygen events occur after long periods of no inundation because there's been a substantial accumulation of organic material in the floodplain. When this water returns to the Murray River, it is low in dissolved oxygen, but the volume of water coming into the river from the floodplain is on a daily basis is small relative to the passing flow of the river. It's very rapidly mixed and diluted, and there's no effect on the dissolved oxygen in the Murray River. And you can see that in the graph. We've mapped or graphed here typical Murray River dissolved oxygen concentrations about 10 milligrams per litre, and then during a managed inundation event at Guttram and Benwell, we've got water low in dissolved oxygen, in fact less than 2 milligrams per litre, so this is hypoxic water entering the Murray River. It has a very small effect on Murray River DO, less than 0.5 milligram per litre at the peak of, I guess, the worst case, and then that effect diminishes over time as the fresh water is brought through the forest during that through flow. So the point of this is that, yes, we could potentially see low dissolved oxygen conditions occur. That's not unexpected, but the consequence of that is low. The other water quality effects that are potentially of concern are around salinity, nutrients and algal blooms. You've heard from Mr. Hoxley that the return of groundwater to the river slightly increases the salt load to the Murray River. The consequences of that in terms of a concentration, so the concentration of salt is very, very small, less than a 0.1 EC unit or microsiemens per centimetre unit. And the extent to which that's accountable under basin salinity management strategy is, I guess, determined by ultimately what that salt concentration is, but it is very small in the context of the salinity in the river. And again, the dilution provided by the river is high, and so the concentration effect is very small. In terms of nutrients and algal blooms, there is a small potential for a small net increase in nitrogen and phosphorus to the Murray River during a managed event. And this is because as that organic material is broken down, not only does it consume dissolved oxygen, it can also release nitrogen and phosphorus that are contained within that organic material. So those nutrients are released to the water column. Some of it is then consumed on the floodplain itself by plants and the like, and some of it will be flushed out into the Murray River. But the net effect is really, really small. And it's not necessarily a bad thing either, and I'll touch on that shortly. The risk of algal blooms are predominantly related to the timing of inundation. Algae are ubiquitous in river systems and wetlands. They're there all the time, and their growth, though, increases during warm weather, still conditions, lots of sunlight, things like that. For the most part, the timing of managed inundation is in winter and spring, and these are before the highest risk period for algal blooms occur. There could be some algal growth occur in parts of in water that's retained on the floodplain after a managed event. So in some of those deeper parts of the floodplain, once all the water's been drawn off the floodplain, there'll be some wetlands and the like that hold water for a longer period of time. We might see some algal growth in those wetlands. That happens at the moment. We might see some poor water quality in those wetlands as they dry out. That happens at the moment. Just in relation to those potential effects, they'd be managed through EDSSW2, and that includes the timing of inundation to predominantly be avoiding those periods of higher risk for algal blooms, providing through flow to provide mixing and transport of organic carbon from the floodplain, help with re-aeration. And if it was necessary, it's possible to control the rate of water being released from the floodplain to make sure that there's appropriate dilution provided with Murray River flows. So if the flow was very low in the river and a managed inundation event was happening, then you could slow down the rate of return if it was necessary. But those circumstances are unlikely to occur, mainly because we're not intending that inundation occurs in every single year. So if it's a dry year and Murray River flows are low, inundation might not be occurring in a year like that anyway. So that risk may never eventuate, but there's a process for managing it. I touched briefly on benefits. The through flow and drawdown and the return of water from the floodplain to the river carries with it dissolved carbon and other nutrients to the Murray River. And that's really important because it underpins riverine food webs. Macroinvertebrates and yabbies consume those nutrients and organic carbon. That's their food, in effect. And then fish eat those organisms that have consumed the nutrients and the organic material that's come off the floodplain. And so in that sense, this inundation of floodplains and the return of that water to the river is important for secondary consumers and riverine processes. And that's one of the things that is missing when we see a reduction in the frequency of floodplain inundation. Now, while that's a benefit, the benefit's still, it's pretty small because we're not talking large areas of floodplain inundation. It's not huge volumes of water coming back into the river. So they're fairly localised effects, but they're benefits nonetheless. I also mentioned that regular processing of organic carbon over time, the more frequent inundation may reduce the severity of low dissolved oxygen occurrences in the future. The operational effects will be monitored through EDSSW3, and through that process we've provided recommendations for sites and variables that would be monitored that would inform the operational phases of managed inundation to assess whether effects are occurring and then to mitigate those effects. I'll talk very briefly about cumulative effects. I realise I'm probably going to go over time here. Sorry about that. We looked at the cumulative effect of multiple sites being inundated at the same time, and essentially the sites are a long way apart. For any individual site, there's very small effects, and so cumulatively there's equally very small effect. I'll now get on to summary of submissions. Submissions raise concerns that managed inundation changes the way water moves across the floodplain, that some areas of floodplain may miss out on inundation as a result of the proposed infrastructure, and that holding and ponding water on the floodplain does not replicate a natural flood event. There was some concerns that, or suggestions that the proposed inundation frequency currently is too often and that forests don't need the water. And then there were some queries around water quality and effects on Ramsar sites. In relation to the water movement on the floodplain and whether areas of floodplain outside of the project areas are going to be starved of water, I guess, or dry. The regulators and spillways are located at key points of flow. And when those regulators and spillways are open, as I pointed out earlier in the presentation, during unregulated flows, water will pass through those into areas of the floodplain outside of the managed inundation extent in the same way that they currently do. So those areas won't be starved of water or deliberately kept dry. In terms of the modes of operation, there are two key modes of operation. There's a flood capture or a hybrid mode, where the intent is as water moves onto the floodplain during a current flood, it might not get as high on the floodplain as desired or last for as long, but the regulators can be closed to capture that water on the floodplain, hold it there for a period of time that extends the duration of inundation, and then release it back to the river. That's the preferred mode of operation because you're using water that's already in the river that's coming with a flood. It's just not as long as you'd like it to be, and so you can use infrastructure to extend the duration of inundation. Pumping is the other mode of operation, where if the floodplain hasn't experienced an inundation event for a period of time and the vegetation monitoring indicates that inundation is needed, the pumps can be used to fill the floodplain. It's not the preferred mode of operation, but nonetheless it fills that gap between natural events. And so in that context, the intent is that inundation would occur during or in relation to the kind of the natural frequency of inundation and maintain connectivity and the timing of inundation events as close as possible to natural, but manipulating those to extend them where possible. I won't go into detail on these graphs for time, but basically we looked at flow data provided by the Murray-Darling Basin Authority and the Bureau of Meteorology to look at the differences in frequency of inundation under modelled natural conditions, baseline or pre-VMFRP conditions, and with VMFRP in place. And it's clear from the data and the evidence, and you've heard it as well, that the frequency and duration of inundation under current conditions is reduced compared to natural. And so these projects aim to increase that frequency and duration of inundation closer to natural in the areas that they can have an effect on. I won't touch on the water planning delivery and submissions as there's been a direction that's already been addressed, and so I'll skip over that.
And the next slide, what's really the summary of this slide?
So this is in relation to those dissolved oxygen effects, and I've talked through those in detail, and so this is just to reiterate the one point I would make, this last point. There was a submission in relation to low dissolved oxygen into Gunbower Creek. There is no return flow from VMFRP project at Gunbower into Gunbower Creek. All of the return flows are into the Murray River, so there is no effect of operations on Gunbower Creek. Briefly in relation to Ramsar site effects, we assessed the effects of construction and operation insofar as they relate to surface water effects on Ramsar sites. We did that in accordance with significant impact criteria and also in relation to the extent that the projects would impact on what's called critical components, processes and services. And for all of those, we believe there's a low level of effect. This is my last slide. EDS were developed with reference to the factors likely to lead to potential adverse effect. As we've gone through, there are 4 specific surface water EDS, and I believe that they relate to construction, operation, monitoring, and that risk around inundation of land outside of the forest. I believe that the EDS are appropriate and will ensure that the environmental effects of the projects relevant to my area of expertise will be suitably managed to achieve acceptable outcomes. The EPA did make a recommendation to some other EDS that have some surface water relevance, and in particular EDS GS1 and GS2. I felt that their recommendations were not necessary because they related to monitoring, and EDS SW3 already includes monitoring of construction and operation, and it includes details on the variables and the location of that monitoring. Having said that, I understand that the day one submission have accepted the EPA recommendations, and I'm supportive of that as well, in the sense if they add clarity to the EDS, then that's fine, but I think they were covered relevantly through EDS SW3 to begin with. Thank you.
Melon, we've got that available to share to the screen if you'd like that shown, that last exchange.
Pop that up, just.
Funny, we just might take the committee through that. So the part where the EPA recommendation, I think, has just been added in there in the blue.
Yeah, so the specific text, where surface water receptors may be impacted by runoff from site work, so this is the last sentence, a baseline turbidity monitoring plan should be developed. Supportive of that. Having said that, the monitoring EDS required that to occur anyway. But for the point of clarity, that's fine. EDS SW2, GS2. Specific measures. Not sure that that's the one actually. We might have got I thought that there was an additional monitoring requirement within EPS GS2. It doesn't look like it's there.
Is it, am I right in saying that when you've had a look at this, you're comfortable with it?
I'm comfortable with what's in there, yeah, in GS2, yep.
Actually bring them back up. Sorry. So it's in SW4. What's on screen? Take me through how that might work. We can read at it. Probably quite familiar.
Yeah, so the modelling identified some very localised areas where there's potential for afflux to occur and for that to result in higher water levels in locations outside of the forest. levy as a result of the infrastructure. So the EDS, the first dot point, requires, or the mitigation is to look at the infrastructure in that location to check how that infrastructure might be impacting on water level, the extent that it's causing afflux, and through the design process, quantify that effect and minimise it through design changes. And so an example, in that particular area along Old Straight Cut and Brereton Road, an additional culvert in the containment bank or a slightly wider regulator might be enough to mitigate that afflux effect. Double checking levee heights in the area where that modelled afflux is occurring to see whether the modelled levee heights match the current levee heights, noting that some works have been undertaken in that area during and following the 2022 flood. And so it's possible that the levees were lower than intended. They might have been damaged or something like that in the model, and the terrain model, the LiDAR picked up those low points in those levees, and that the water's flowing through those low points. If those low points were patched up to the intended levee height, then that may mitigate the risk as well. So they're the sort of the practical on ground and design measures to prevent that effect from occurring.
I think we've probably covered this off, but just checking you've reviewed the day one EDS and you're comfortable with the changes that have been made. Yep. Oh, and I will cover off the koalas, not the koalas question, the friends of the koalas question. You heard Mr. O'Farrell's response. Yeah, okay, just making sure. Okay, all right, thanks. Was there any other questions?
Thank you. Can Dr. Treppel be excused?
Okay, yeah, no problem. Thank you.
Can I also indicate, Member Elliott, just in relation to your inquiry about that, that you've crafted in a way that Stephen has that.
Yes.
So under no circumstance would there be a private landowner where they're affected unless they agreed to it. It's hard to immediately contemplate a circumstance where a landowner might agree to it, but they might have a feel or something where they're comfortable with it, but then there's some sort of arrangement. But that's drafted so as to enable agreement from a private landowner, but the committee can proceed on the basis that there wouldn't be afflux on any private land unless there's an agreement in place.
Well, we've come to the end of 2 days. Is there anything else you wanted? I think you could send through a copy of your response to the questions. You might have already done that, but if you could just get that file, that would be great.
Yes, we'll do that. So we might need tomorrow by the look of things. So it brings us to Wednesday and Thursday. Yeah, so I don't think there's anything else we can usefully do today.
No, and I think we did have a think about whether we'd change the timetable, but I think there might be other parties who are planning Wednesday, Thursday, so we'll keep things as they are, and I'll get Salvaraj to send an email out to everyone just letting them know of the change. I'll just check online. Was there anyone listening in who had any questions about anything to what's happening from here? No, okay, all right. Well, we'll finish for today and we're going to return on Wednesday. So we'll come back at 10 a.m. on Wednesday, the 1st of July. We might move into room 2, just that buzzing, just always coincides with the time someone wants to talk. So we might end up being in room 2, but we'll just confirm that before the day as well. So thank you for running through the witnesses very efficiently.